Welcome to Smart Architectural Programming, your foundation for better, cleaner, and smarter code. In today's episode of Introduction to Java, we dive into a fundamental yet often misunderstood concept, throwing exceptions in Java. And this is a very crucial topic that you need to understand because it helps in debugging and it helps making sure your code doesn't break when it encounters things that it doesn't understand. So without further ado, let's push into what are exceptions first. So you might have seen a previous video where we explained exceptions, but it's better to have a quick recap of the concept before we dive into throwing exceptions themselves. So before we throw anything figuratively, we need to understand what exceptions are. Exceptions are Java's ways of saying something unexpected just happened that I don't understand. Maybe a file wasn't found or the user tried to divide by 0. So please take a look at it and try to make sure that I'm able to understand this in the future. So that is what an exception is. And as you can see here, let's bring our trusty marker here and change the color to red to make it a little more apparent. When you divide 10 by 0, it's going to throw an arithmetic exception error. You can't divide anything by 0. And that is all an exception is. It's something that Java can't understand or can't process. This triggers an arithmetic exception error that I mentioned, and Java halts your program unless you handle it. But sometimes you want to manually throw an exception when something isn't right. That's where the throw keyword usually comes in. So what is the throw keyword? In Java, we use throw keywords to manually create an exception. You create an instance of throwable, usually a subclass of exception, and throw it. What does that mean? It means, as you can see in the code here, we're telling Java to stop and report that something went wrong on our terms. The syntax is straightforward and continue working on the code. Basically, tell us what's wrong and just focus on processing the rest of the code. So here we say a throw new illegal argument exception, invalid age entered, throw new exception type, optional error message, void register user, so on and so forth, right? Throws IO exception. So you throw these errors to make sure you know where something code might have been broken, but make sure that it keeps on running as well. So next thing you need to understand that once a throw is encountered, the rest of the method doesn't continue. And if you're throwing a checked exception, you'll need to declare it with the throws keyword. So with that, let's focus on creating custom exceptions. So what are custom exceptions? Sometimes Java built-in exceptions don't quite describe your situation. Let's say you're building an architectural planning app, or you want to throw a floor plan not found, right? So how do you do that? As you can see this code here, this is a custom exception. We define this custom exception that extends the exception main class and creates a subclass floor plan not found exception. So you using this, you make it a checked exception, basically when you extend the main exception class. You can also extend runtime exception itself if you want to do an unchecked exception. And you know the difference between checked and unchecked exceptions. Go back to our previous video on exceptions themselves. So let's use our floor plan not found exception method in understanding how throwing custom exceptions work in practice. So you see this code base here, right? It is a code base where we're throwing floor plan not found exception error, and then we're basically setting that up. Now your method clearly communicates what can go wrong and gives you flexibility to handle it at a higher level, basically. So what are some best practices for throwing exceptions? Here are a few best practices to keep in mind when throwing exceptions in Java. Number 1, use standard exceptions when possible. Illegal argument exception, null point exception, so on and so forth. Number 2, creating custom exceptions for domain-specific issues. Number 3, always provide meaningful messages. And number 4, don't overuse checked exceptions. Use them when recovery is accepted. So I think with that, we're going to wrap this video up. Let's review what we've learned today. The throw keyword allows us to manually trigger exceptions. The custom exception helps create readable, maintainable code. Use throws keyword in your method signature when necessary, and custom exceptions equal better problem communication in large apps. So to wrap up, if you found this helpful, don't forget to like, subscribe, and hit that bell icon so you don't miss the next chapter of our Introduction to Java series. This has been Smart Architectural Programming, making software engineering smarter, one class at a time.